Hello, my name is Chuck Moses, and I would like to talk to you today about protecting pollinators from pesticides. Recent events have brought attention to this issue. You may have heard the acronym CCD, which stands for Colony Collapse Disorder, which is the name given to a disease recently affecting honeybee health. Pesticides may be a contributing factor, but there are other factors that can be linked to the disease. These include lack of available forage and nutrition, genetic diversity, beekeeper practices, pests, and diseases. Although we will be talking about these other factors in this presentation, we will be focusing on pesticide use practices. If we are focusing on pesticides, let's talk about some of the products we use to control pests. Many of the products are toxic to insects, especially our insecticides, and most are non-selective. The trouble is, we just can't target the problem insects. We are going to kill a fair number of beneficial insects as well. A relatively new class of insecticides fall into this category, and they are known as neonicotinoids. These products are relatively new, and many of you may be familiar with them. They are used in agricultural and non-agricultural sites and are valuable products if used according to label directions. These products have also been implicated in recent bee kill incidents. When we look at natural products bees collect, we find that pesticide residue may be present in these products. With many pesticide products, if a bee receives a toxic dose of pesticide, they will generally die away from the hive. Trying to find a bee to sample makes it difficult to determine the causal agent. If a bee does not die away from the hive, it will return and die in the hive later, where worker bees will then push the affected individuals out. However, in cases where neonicotinoids were involved in a bee kill incident, it was determined that the bees generally will not return to the hive. When bees collect pollen and nectar, they return to the hive, and because of the way these products are made into honey, usually the honey will not become contaminated. If pollen contains pesticide residue, bees may collect it and it will be stored in the comb. The pesticide residue will kill nurse bees and brood if present in sufficient quantities. If a colony receives a non-lethal dosage of pesticides, it will take a while for the colony to return to full strength. Beekeepers may notice a reduction in honey production or notice a drop in the number of active bees. Bees may appear sluggish or sick, although this may be a result of environmental issues like temperature. If a pesticide was involved, this would be considered a subchronic effect, and the colony may return to good health over a period of time, possibly several weeks after initial exposure. If a substantial number of bees do not die, recovery of the colony will be possible. This particular article was found in a newspaper called The Independent. In 2013, it was suspected that neonicotinoids were involved in a number of bee incidents in Europe. Germany took steps to cancel the use of these products for a short time. Without having a complete data set and not knowing if the pesticides were primarily the causal agent, this step was taken more to err on the side of safety. Later on, the cancellation was lifted, but there were still restrictions placed on use in Germany and other European countries. This also made news in the U.S., but we had no awareness of incidents in this country at that time. That changed in June of 2013 when there were two incidents involving dinotefuran, a neonicotinoid, the active ingredient in Valent or Safari, in a 2-week period, which just happened to be Pollinator Week in the U.S. Both incidents involved a large number of yellow-faced bumblebees and took place in ornamental, not agricultural sites. A total of 59,000 bees were killed in both incidents. There were enforcement actions taken by the state agency for some label violations, but it was determined after the investigation that there were some issues associated with legal use of the product, which contributed to the incident. As I mentioned in the previous slide, it was determined that there were a number of issues related to legal use of the product that may have contributed to the incidents. Number one, and which was no surprise to anyone, the products used were highly toxic to bees. Secondly, pesticide residues were detected in pollen and nectar samples. A major finding was that the pesticide can persist in soils for months or even years after a single application. Not surprisingly, since the application is designed to last an entire season, these products will last a long time in the soil. Since these products are systemic, pesticide residue can remain in a plant over a long period of time as well. Another significant issue is that use rates in ornamental settings for soil injection can be up to 120 times higher than agricultural use rates. Finally, there was no definite link to colony collapse disorder in the incidents investigated. In June 20th of 2014, with evidence that pollinator populations were on the decline nationwide, a presidential memorandum was constructed to create a federal strategy to promote the health of pollinators. The memorandum established a pollinator health task force made up of federal agencies, including the U.S. Environmental Protection Agency, or EPA. A major task assigned to the task force was to develop an action plan to focus federal efforts on understanding, preventing, and recovering from pollinator losses. Activities of the task force include conducting research, increasing pollinator habitat, and incorporation of conservation practices. The EPA was directed to assess the effect of pesticides. In order to increase awareness of the problem, state governments took steps to reverse pollinator declines and restore pollinator resources by directing efforts of state agencies to accomplish this goal. This executive order from the state of Minnesota outlines specific tasks for individual state agencies and limits the use of neonicotinoid pesticides and plants treated with neonicotinoid products in the Capitol complex. It was suspected that there would be incidents in other parts of the country involving neonicotinoids. Part of the problem is that there really is no substantial data which would demonstrate without a doubt that neonicotinoids were the primary causal agent related to bee kill incidents. For that reason, US EPA could not take steps to cancel the use of these products. So instead, they conducted a limited risk assessment for the use of imidacloprid, a widely used neonicotinoid pesticide. Their findings were as follows. The pesticide imidacloprid is mobile, soluble, and systemic. It is transported by the roots to the pollen and nectar, and bees are exposed by contact and ingestion. Adults are more sensitive than larvae, and if pesticide residue in the bee is below 25 parts per billion, there will be no observed behavioral or health effects. The study was limited in that it was confined to the use of imidacloprid in agricultural situations only. The study will be expanded at a later date to include other variables. Other findings included that pesticide levels in nectar vary with soil type. Pesticide residue is higher in silt and clay versus sand. Limited data produced in this study suggests that honeybee data is protective of bumblebees and solitary bees. This is an important finding which I mention later in this presentation when I talk about the Voluntary Pollinator Protection Plan. The highest risk to honeybees is in citrus and cotton. Dust samples were not collected in this study, but many contain pesticide residue. Bees may inadvertently collect dust when collecting pollen and nectar. An additional study is slated for completion in 2017, which will examine dust and risks to other pollinators. The Nevada Department of Agriculture is the state agency responsible for assuring that pesticides are applied in a safe and legal manner. Priorities of the agency include protection of human health and the environment from the adverse effects of pests and pesticides. In addition to this, promotion of integrated pest management and professionalism within the pest control industry through education and compliance assistance are priorities of the department. Persons interested in finding information about pollinator protection can visit the department's website at www.agri.nv.gov. Pollinator information can be found on the department's entomology webpage. A sample of information that you will find on the site includes a fact sheet on pollinator health. The Department of Agriculture received many calls about efforts to protect honeybee health in 2013, so it was decided that a fact sheet on this issue would be developed for persons interested in getting more information. The contact information for the state entomologist is also on this fact sheet if additional questions need to be addressed. Page 2 of the NDA fact sheet addresses concerns about raising bees in an urban environment and is designed to educate people about CCD. The fact sheet indicates that there are approximately 2,500 species of native bees in Nevada. These include leafcutter bees, alkali bees, and blue orchard bees, some of which are managed populations. Unfortunately, populations of non-native species, such as Africanized bees, have invaded some areas, and this presents a challenge for pest control operators and beekeepers who are on the front lines of controlling the spread of invasive species. Also on the NDA webpage is a link to a fact sheet produced by the Washington State Department of Agriculture. This is a good resource, and if you continue on to page 2, you will find specific measures that an applicator can implement, some voluntary, some mandatory, to better protect pollinators. Specific measures on page 2 include applying pesticides during a time when plants are not blooming or when it is evident that bees are actively foraging. Applicators can wait until flower petals have fallen and use less toxic pesticides to control pests. Reducing application rates and implementing non-chemical control measures can result in long-term pest control and will result in lower pesticide exposure to pesticide pollinators. Mandatory steps applicators must take are discussed later in this presentation. Applicators are required to read and follow pesticide label directions since they change frequently. The U.S. EPA has approached state pesticide regulatory agencies and asked states to develop specific pollinator protection programs tailored to their needs. EPA has contributed information which can be found on their webpage that will assist all persons, not just pesticide applicators, to protect pollinators. One of the best things about this page is that EPA talks about the many stressors which affect pollinator health and not just pesticide exposure. There is a discussion of CCD on this webpage, and as I mentioned earlier, there are many factors which might contribute to CCD. There is also a place on this webpage for persons to report a suspected pesticide poisoning incident. The information will be forwarded by EPA to the state regulatory agency responsible for looking into these incidents. In the past, beekeepers have claimed that many incidents go unreported or are not investigated at all. This issue has raised awareness among state regulators, and EPA has developed this link to make sure there is no failure to take action when pesticides are involved. A cooperative effort between stakeholders is necessary to make sure we do all we can to protect pollinators. Although there are many steps members of the public can take to protect pollinators, the stakeholders we are talking about include growers or landowners, applicators, and beekeepers. Agricultural growers can choose to use pesticides that are low in toxicity. In addition, growers can alert beekeepers of an upcoming pesticide application, by giving beekeepers 1 to 2 days notice so that beekeepers can take appropriate measures to protect their bees. Applicators must follow label directions and utilize best management practices, which include implementing integrated pest management or IPM. Applicators should not spray pesticide when crops are in bloom and bees are actively foraging. When applications must be made, they must be made during a time of minimal bee activity. This usually means evening hours or between the hours of 8 p.m. to 8 a.m. In the summertime, it gets lighter earlier and darker later, so applications can be adjusted. A best management practice that can be implemented during any pesticide application includes managing or minimizing spray drift. By establishing buffers between treated areas and pollinator habitat or colony locations, we can limit the amount of pesticide residue which might reach the colony. By checking weather forecasts prior to making an application, we can be sure that the temperature variation will not be detrimental to our application, and we can be sure the wind will not be blowing toward a sensitive area. Some other things we can do are choosing low pressure spray nozzles which operate with lower pressures and create larger spray droplets. And we can minimize vapor drift by applying pesticides when the temperature is below 85 degrees. Pesticide residue does not break down rapidly in cooler weather. Conversely, warm weather does break down pesticides more rapidly and would be more protective of pollinators. Of course, we want our pesticide products to be effective, so we have to make sure they stay around long enough to do their job. Newer pesticide products are designed to break down more rapidly than older products, such as chlorinated or organophosphate pesticides. We modify our spray practices according to weather variation. Unfortunately, bees also modify their behavior, so if we are spraying during warmer weather, bees are active longer. If wind is blowing in a direction where a colony is located, there is a great risk of having an adverse effect. If we don't know where bee colonies are located, we can consult with farmers, landowners, or in some cases, nurserymen. One of the tools I will be talking about later is the establishment of a pollinator protection plan. The pollinator protection plan establishes a searchable database that pesticide applicators can access to find out if there are colonies located near the application site. Beekeepers must register their hive locations so that this tool can be effective. Some weed species are attractive to pollinators. In some situations, weeds are the only forage plant available. So when we apply herbicides, we should be aware of this fact. If it is evident that plants are in flower and bees are foraging, we may be able to adjust our application timing to avoid those time periods.